And ta-da! There we go. So, you guys see that? Everything's all right? Yeah. Good. Return to meeting, everything's okay. All right. Just a bit of a hectic morning here. But how are you doing there, guys? Is everything okay? I think there's still the two of us. I can't see who's in the meeting here, but everything's good, Elena. Very good. For all the people there who are enjoying their morning sleep, it's all good. I'll still post this there to YouTube. And if you don't know me by now, it's week 10. My name's Ian Coates. I'm your instructor for this course. And quiz 2 marks are posted. It was a tough quiz, and it was a tough test. That's just the nature of the beast. And but marks are still good. Everything's going all right. I did put zeros up there. I sent an email or I sent an announcement about this that if you get a 0, I'm not trying to burn you. I'm not giving you a 0, The only reason a 0 is there is because I can't find your quiz or your test or assignment or whatever, and you have to understand that it's pretty mayhem-ish, on my end, and that's all right. It's not your concern. You guys have enough to do. But I've got assignments coming in through Blackboard. I've got chemistry and nutrition assignments coming in through Blackboard now that the wrong assignment's been uploaded. So then that assignment there, the person has contacted me, and I've got assignments in email and lab partners, like for the case study there. I've got missing partners that were supposed to be on the sheet that aren't on the sheet, and it's just it's crazy. So first thing how I do it is I go through Blackboard and I do all the assignments on there, and then I cross-reference there with my email to see if those people who I didn't see an assignment for on Blackboard, I check on email. I might miss something or not. So my system, and I don't want you guys to be offended or email me in all caps, I handed in the assignment, and why did I get a 0? If you got a 0 and you handed in the assignment, just email me and say, hey Ian, I see I got a 0 on the assignment. I emailed you on this day, March 22nd. Here it is, and then I'll go and check it and I'll get the marks going. Okay, so that's how this goes. 0 doesn't mean a 0. It just means I can't find it. And you know what I mean? I'm human. I go through my emails. I check this and that, and I might miss it. So it's all right. How are you guys doing? Are you guys doing okay? Everything's all right? I hope you guys are doing all right. If I'm hoping there that the test 2 will, the marks will be posted there. I'm hoping they're later tonight. It's just, if I just had paper tests, that's not a problem. I could just zing through them, but Blackboard is pretty slow. So, yeah. I just need to, I've got another test going on. So if you, yeah. I think it's going all right, but we'll have to have a look here. Sorry, and where are we here? Sorry, this is completely unrelated, but I've got another test going on here, and I think it's okay. And yes, it is good to go. All right, so that's all I needed to know. Good. Okay, so what's going on there for week 10, I sent another announcement out there that details what is happening there for the remainder of the semester. And there we go. And announcements, yeah, right here. So this week and beyond, here we've got, this is week 10, probability. All right, it's not bad at all. Like probability there, the chance of rolling a 2 with one dice. you know. That's all we're talking about there today. We're going to talk about probability and odds. And this will carry on to next week, where we're going to continue, the normal distribution, with the standard deviations and all that. And so just to tell you guys there that week 10, this is a new lecture. We're going to deal with that there today. Week 11 is a new lecture, normal distribution. Week 12, there is no new information. So week 11, next week, is the last week of new information. Okay? And week 12, we'll just use as a review class. Your quiz 3 will go out. Okay? And then week 13 is your test 3. Okay? I forgot to mention there that your second assignment will go out there later this afternoon. I really enjoy the paper-based tests because I can see your marks. And if you get the wrong answer, then I can go back, and as long as you've shown me work and your methodology and you use the right formula, and then I see here in step 3, there's a calculator error, then I can still give you marks. All right, so that's where it is, but it's very time consuming, as you can see, and marking these things electronically through Blackboard. Blackboard's pretty slow. So I'm going to try and get the assignment there as a multiple choice. I'm working on it. I'll have something there this afternoon. I'll send you guys an announcement there about assignment 2. You'll have 2 weeks to do it. So assignment 2 will be due week 12. Okay, it's all written right here, and you guys can check the syllabus and that kind of stuff. Yeah, so we got assignment 2 going out there this afternoon. Quiz 3 goes out week 12, and then test 3 is the last week there with no class. Okay, so I hope you guys are doing all right. You guys have any questions? Anything at all? Nah. Shut up, Ian. Let's get on with this. Perfect. All right. Probability and odds. Okay. What we're going to be doing there today, we're going to talk about probability and odds. We're going to go through some definitions. And you know what definitions mean, you know what I mean? It'll probably be some matching or something, And we're going to talk about additive and multiplication rules for probability. Again, are they that difficult? No. And then there's lots of questions here that I've given you. Okay, so what does probability mean? Okay, and I'm just going to try and move that over there. Perfect. Now, you guys, I took this there from a previous lecture. You know what I mean? The numbers aren't important in all this. I just kind of stuck it over here because you guys have actually seen probability already. I just didn't call it probability. So, let's have a look here. Let's move that over there. Perfect. So what do we got here now? Come on, just shimmy over. Probability, P. The number of desired outcomes divided by the total number of possible outcomes. So like just the whole idea, if I have a 6-sided dice, and there's 1, 2, 3, 4, 5, 6 on the dice. If I roll the dice, what is the chance of getting a 2? Well, according to the formula here, probability, I'm looking for a 2. Okay, so 2 on top, total possible outcomes. All right, the number of desired outcomes, I'm looking for a 2, so it's a 1 divided by, there are 6 choices, and 1 divided by 6. And you guys have actually seen that. Okay? Remember your relative frequency? 1 divided by 30 gives you 0.033. Okay? We've seen this there before. We'll cover this. It's not too bad at all. The opposite of probability is called the complementary probability. And the number of undesired outcomes divided by the total number of possible outcomes. So if we go back to this one here, if I wanted to know the probability of rolling a 1, okay, So I'm looking for 1. 1 divided by 6, that gives me a probability. But the complementary probability is what's the chance of rolling opposite? So not a 1, but a 2, 3, 4, 5, or a 6. And it's the number of undesired outcomes divided by total possible. That doesn't look right. There we go. Oh, that looks good. Okay, so 2 formulas there, not too bad. And there are some rules of probability. Sorry, mosquito. The probability of any event E is a number, either a fraction or a decimal, between 0 and 1. So probability is all about between 0 and 1. And we'll show you these. I'll show you some little tricks here. So this is denoted by the probability of an event is between 0 and 1. It cannot be negative and cannot be greater than 1. We'll show you this. If an event E can't occur, the event is not included in any possibility, its probability is 0. So if I have a 6-sided dice, okay, what's the probability of rolling a 7? 0. Ain't gonna happen. End of story. Next question. So, and that's what the example is here, okay? So when a single dice is rolled and the probability of getting a 9, since the sample space, I like that word, I like that terminology. What's the probability of rolling a 9? Well, since the sample space, and that just means the total number of outcomes. The sample space is 1, 2, 3, 4, 5, 6. It is impossible to get a 9. Hence the probability. And you see that I like this terminology here. The probability of rolling a 9 is 0. Okay? If an event is certain, meaning 100%, then the probability of the event is 1. So 1 means 100%. When a single dice is rolled, what is the probability of getting a number less than 7? Well, when a single dice is rolled, the solution probability of getting a number less than 7, 6 out of 6, which is 1. And I'll show you, there's little tricks here. Not too bad, though. The sum of the probability of all outcomes in a sample space equals 100%, equals 1. So the chance of rolling a 1 plus the chance of rolling a 2 plus the chance of rolling a 3 plus the chance of rolling a 4 plus the chance of rolling a 5 plus the chance of rolling a 6. If that's all the possibilities in your sample space, if that's all the numbers there that can be rolled, if you add them all up, they always equal 1, which is 100%. Okay? I got a little bit of a math review there. We'll go through this kind of stuff here. But here are some examples here. What is the probability of rolling a 4 using a dice that has 6 sides? Well, I'm looking for a 4, so that's one of the numbers there. 1, 2, 3, 4, 5, 6. There are 6 numbers. I only want one of them. So it's 1 divided by 6. And if you in your calculator, 1 divided by 6, you could have the fraction, you could have the decimal, or the percentage. And this is one of the things there I want you guys to practice on. And I gave this to you here. You can print it off or on a piece of paper, just do the same thing. This, where we're going there for this week and next week, you have to be able to interchangeably go from a fraction to a decimal to a percent. So if you get the fraction, it's pretty easy. 1 divided by 2 is 0.5. Multiplied by 100 gives you 50%. All right? And if you give you percent, okay, here's 80%. How do I change this to a fraction? Well, percent means out of 100, right? So this means 80 out of 100. So for a fraction, you'd put 80 divided by 100 You could reduce this to 8 out of 10. You could reduce it again to 4 divided by 5. And then divide 4 by 5, and you're going to get an answer here of 0.8. Right? 80%. The decimal is 0.8. So try some of these. I didn't post these answers here, but if any of them are bothering you, just shoot me an email. This one here, I can't stress it enough. Mucho importante. You gotta be able to do this, because I might ask for an answer in a fraction form. I might ask for it as a decimal. I might ask for it as a percentage, because this is where we're going to be heading there next week. Okay, for normal distribution. Because you remember there on the quiz, there wasn't really any major, I was a bit tougher on the marking about rounding. And I sent an announcement out and all this kind of stuff. Be careful of your rounding. Some people are rounding too much. Like an answer there of 2.57. People are rounding to 3. Don't do that, okay? Keep it as 2.57. Keep those numbers, because especially in the, remember that standard deviation, like a massive table. Sorry for that, but we're going to see it again. I hope it wasn't too bad. But on those standard deviation, where you have the mean and then you subtract the number from the mean and then you square it and then you add them, you know what I'm talking about, right? Some people were still rounding at the beginning, which affects the end result of the standard deviation. So I took some marks off there. Marks kind of dropped a little bit. It's all right though. This is way tougher than where we've been there before. Okay, so try these out. See what you can do. If any of them are bothering you, shoot me a WebEx or shoot me an email and we'll fix it up. But this one here is crazy important. Okay. So what was the probability of rolling a 4? Using a die, so it's 1 divided by 6. There you go. What is the complementary probability of rolling a 4? So this is the opposite now. I'm not looking for the 4. I'm looking for the chances of rolling a 1, 2, 3, 5, 6. So it's 5 numbers divided by the total, which is 6. There's your decimal and there's your percentage. Okay. This one here. This one's a good one. What is the probability of rolling a 9 using 2-sided dice? Okay. So you're thinking 2-sided, you know what I mean? How do I do that? Well, what numbers, because I only have 2 dice. So what 2 numbers add up to a 9? Well, 1 and 6, no. 2 and 5, no. 3 and 4, 3 and once you figure it out there, it's 4 and 5 add up to a 9. So you could have a 4 on one dice and a 5 on one. There's 1. And then roll it again. You could, same dice there, I could have a 5 and a 4. Just flip, right? So there's 2. 3 and a 6. And then 6 and a 3. So we have 4 combinations that can go on here. And this one here is kind of a pain in the butt. I would know, I'm giving you this one. If you have 2 dice, all right, there are 36 combinations. And actually, you could figure them all out. It's all right, But there's 36 combinations there. So you have 4 possibilities divided by 36 total. And that gives you 1 divided by 9, which is 0.11, which is 11%. All right. So you will see these again in some fashion or form. Okay. So a good little thing here I want you guys to notice as well. The probability of an event plus the complementary probability of that same event. So the chance of rolling a 4 plus the chance of not rolling a 4 equals 100%, equals 1. That's a nice one. I like it. Okay, so a couple of formulas there. That's what's going on right here. The sum of the probabilities of all the outcomes in a sample space is 1. And you see here, in the roll of a fair dice die, it sounds weird. Each outcome has a probability of 1/6. So the chance of rolling a 1 is 1 out of 6. The chance of rolling a 2 is 1 out of 6. 3, 4, 5, 6. Okay, if you add them all up, 1 over 6 plus 1 over 6, that equals 6 over 6, which is equal to 100%. Okay, which is kind of the same thing here. The chance of an event happening plus the chance of the event not happening has to equal 100%. Okay, try these out. They're absolutely relevant to where we're headed. Now, playing cards. And these are the, I'm not promoting gambling. I'm not promoting anything that is, these are just playing cards. It's just a game. Okay? And they work really well with where we're going here. And just a couple of things here. If you are not familiar with Western style playing cards, you know, there are 52 cards in a deck. There are 4 suits. And what I mean by suits are, I don't know, flavor, color, not color, but there are hearts, diamonds, spades, and clubs. Okay, there are 4 suits. All right. Hearts and diamonds are red. Spades and clubs are black. Okay. So there are 13 of each. So 13, 13, 13, 13. If there's 13 hearts, 13 diamonds, 13 spades, 13 clubs. 13 times 4 equals 52. Now, of those 13, there are 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, queen, king, ace. Okay? These ones here have faces on them. Okay? And you know what? Have a look at a deck of cards. You don't have to buy one. Just have a look on online. Just Google deck of cards and you can see all this. Because we will be utilizing this. Okay? And sorry if you're not familiar. If you're not familiar with these, we'll get you guys through. Okay? Just shoot me an email and we'll get you guys through. So a standard deck of cards has 52 cards. What is the probability of selecting an ace from a standard deck? Well, there's 4 ace. There's an ace of hearts, an ace of diamonds, an ace of spades, and an ace of clubs. So there are 4 aces in the deck. Divided by 52 gives us a decimal and a percentage. Okay? And again, if there's any issues in being able to convert these, let me know. What is the probability of selecting a red face card? Okay, and what we're talking about here, what is the probability? So you've got a deck of cards, or you've got a bag of marbles, right? And you've got 23 green marbles and, I don't know, 25 red marbles. And what is the chance of, what is the probability of picking it? At random, right? This is what we're talking about, randomly choosing. Like this is chance, right? So what is the probability of selecting a red face card? Jack, queen, king. So, and you see here, answer in fraction, decimal, percent. So there are 3 face cards per suit. All right. So there's 3 jacks, 3 queens, 3 kings for each of these. But you'll see there, maybe I'll just do this. Just to let you guys know that they are these guys here are the red ones. These guys here are the black color. Okay? So here we're looking for a red face card. Well, you've got 3 red face cards in hearts. You've got 3 red face cards in diamonds. So what's my sample space? 6. All right? So we're looking for 6 cards out of 52. There you go, 11.5%. Okay? Anyone who's into poker, they already know these numbers there, these kinds of things and all that. But this is not gambling. We're just talking about probability, chance here, which we will take with us there next week and the week after and be all over the final test. Okay? These are very important. There's These two, there's something called theoretical probability as opposed to empirical or experimental probability. And theoretical probability is based on the reasoning there of this formula here, number of desired outcomes divided by total possible outcomes. That's the same formula I showed you there on slide 1. Okay? And like the example is if you flip a coin, okay, a coin there, you've got heads on one side, you've got tails on the other. Okay? And what's the probability of getting a head? Well, you've only got two. You've got heads and tails. So if I'm looking for flip a coin there and I'm looking for heads, or you could look for tails, doesn't matter. You've got 1 divided by 2 possibilities, which is 50%. Makes sense, right? That's your theoretical probability. Look at if you decided now to take that coin and flip it 5,000 times and record each head and tail, head and tail, head and tail, is it going to be exactly 50%? Nada. No. Is it going to be close to it? It should be. All right? But your actual data, it will reflect the theoretical probability, but it won't be exact. And you see here, if we flip a coin 5,000 times, here's you count the heads, and you got 2,850 heads, and then what's 5,000 minus 200? That's what? 2,150 tails. Well, hey, that's not 50%. It's not going to be either, okay? Because, you know what I mean? The coin could be some imbalance on the coin when it was minted. You know what I mean? Maybe there's so many different reasons why this coin didn't come out 50%. But, and you see here, we got 2,850 heads divided by 5,000 total times. We actually got a number of 57%. Now, we know that this is the empirical data, and what do you think would happen? Here, I flipped the coin 5,000 times. What if I flipped it 10,000 times? What if I flipped it 500,000 times? What if I flipped it 1,000,000 times and recorded it all? What do you think would happen with this 57%? It would actually start to get closer and closer and closer and closer. So if I flip this coin 10 billion times, it would probably get to close to 50. And it's something called the law of large numbers, which we'll get into. Okay? So, theoretical probability, theoretical. Empirical probability, actual data. So, here we go. Welcome to these charts, which you'll see there for the assignment and all this kind of stuff. And by the way, if you just joined late, we're just going through probability. Your assignment will go out there later this afternoon. I'm trying to get it into a multiple choice form so that I can put it on Blackboard, because marking these quizzes and all this kind of stuff is it's all right, but I'll see if I can get this onto Blackboard in a usable fashion. But you see this chart here. Here we've got males and females born in Canada, born outside of Canada, and you got your totals on all sides. Like what I would do on a test, or I would give you all this information in here, okay, and you would have to fill in all this. So where did this 46 come from? Well, it came from the total number of males in the study, 25 and 21, 46. Total number of females is 38 and 34, okay, and the total number of females in the study were 72. In this study here, the total people born in Canada were 63. The total people born outside of Canada were 55. Okay, so you just add these columns up and you add these rows up to get these numbers here, and you'll see there that the total number of people in the study were 118. If you add 63 and 55, you get 118. If you add 46 and 72, you get 118. Good. So, What is the probability of being a male? Now, what does this mean is here, we have this study of 118 people, and we've asked them and we've got this information, right? So, at random, what is the probability of choosing a male? Well, all right. So here we've got total number of males in the study is 46. Right? That's the total number of desired outcomes divided by the total number of outcomes, which is 118. And you see here, I've just given the fraction. You guys can do the decimal and the percentage. Okay? So 46 divided by 118. What is the probability of being a female? Well, right there. No. Is it here? No, it's here. Be careful. All right? Because you've got two different sets of data. One going this way and another one going this way. Really neat chart. It breaks things up. And that's what the whole point of a chart or diagram or a graph is. It breaks things up so you can take the information out. So total probability of being a female, 72 divided by 118. There you go. Find your percentage, away you go. What is the probability of being a female born outside of Canada? Well, okay, all right. Female born outside. Female is in here. But what do we got here? And yeah, that's a mistake right there. Say 34. So a female born outside of Canada. 34 divided by 118. I'll update this PowerPoint there on Blackboard. Okay. Are we using empirical or theoretical probability here? Well, this is an actual study, and if it's an actual study where we've gone, we have people there and we've asked them questions, this is empirical, experimental data. Okay, let me know if you guys have any questions on that. I don't think it's too bad. Okay, something weird going on with the computer. Going back to where we were there before, I mentioned there the law of large numbers, okay? States that as you increase the number of trials, the empirical or experimental probability will move closer to the theoretical probability. And it's just like what I was saying there. If we flipped a coin 5,000 times, I got 2,850 heads and 2,150 tails. Well, all right, that's my empirical data. That's what it is, right? But if I flip that coin 1,000,000 times, if I flip it 2,000,000 times, 10,000,000 times and record it all, the law of large numbers states that the empirical data will shift, will move closer to the theoretical probability, which is 50-50. Okay, so that's a good one. Probabilities range from 0, the event never happened, to 1, the event is a sure thing. Just a little recap there. Hopefully that's all right. Let me know if that gives you any trouble. Here's another definition with another formula. The odds, and we've all seen this, right? What are the odds? We've actually all said that. What are the odds of this happening? It's actually a saying, right? And what does this mean, the odds? Well, it's related to probability, but it's a little different. And have a look at the formula here. The odds of an event happening is equal to the number of desired outcomes, what you're looking for, divided by the number of undesired outcomes. So let's go back here. You remember this one here, the probability of an event, the number of desired outcomes, same as the odds formula, all right? But for probability, it's the total number of outcomes on the bottom, on the denominator, okay? For odds, it's the number of desired outcomes divided by the number of undesired outcomes. Okay? Why is that so slow? I don't know what's going on here. So, the number of desired outcomes divided by the number of undesired outcomes. Or, preferably, the number of desired outcomes to the number of undesired outcomes. Now remember, a fraction is just a ratio. If I have 1 over 2, it would be 1 to 2. Sorry, bad example. Let's say I have 1 over 5, 1/5. Then it would be 1 to 5. And I mean TO. All right? And the example here. The odds of rolling a 7 with 2 dice are 6 to 36. Okay? So this is where we're at right there. Let's have a look here. There's lots of questions here, and we'll get into all these right here. Finding the probability versus the odds. So 11 poker chips are numbered consecutively 1 through 10, with 2 of them labeled with a 6 and placed in a jar. So 11 poker chips. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And I throw in an extra 6. So I have 2 6 chips in a jar. And you close your eyes and you grab a chip. All right. So here's your probability. 2 divided by 11. All right. Chances of, there are 2 6s in the bag. There are 11 chips in the bag, so 2 divided by 11, which I think is 0.11, which is 11%. Okay? Find the odds of drawing a 6. It's the number of desired outcomes, which is still 2. Now the number of undesired, which is 11 minus 2, which is 9. So how we say this here, the odds of drawing a 6 from the jar is 2 to 9. That's how we verbally say it. Okay? 2 to 9. All right. Find the odds of not drawing a 6. Okay? It would be I don't like that one there. Something's wrong with that. The odds of drawing is the odds of not drawing a 6. So that would be 7 over 2. Oof, man, I thought I checked this over. I did 3 times. There we go. We got 7 divided by 2. All right. But let's go. Keep going here. Finding the odds. 11 poker chips are numbered consecutively 1 through 10, with 2 of them labeled with 6 and placed in a jar. The exact same here. So find the probability of drawing a 6. 2 divided by 11. Here we go. We got that one here. A chip is drawn at random. Find the odds of drawing a 6 and find the odds of not drawing a 6. What happened downstairs? Okay, hopefully everything's all right here. And you have a look here, and it's the same thing here. The odds of drawing a 6 is 2 to 9. We read this, we speak it as 2 to 9. The odds of not drawing a 6 is 9 to 2. And we speak that there, 9 to 2. And note there that the percentage there for odds, okay, it's only X to Y. We don't use a fractional form. Okay, so for odds, for probability, we can use fractional form, decimal. We can use probability, percentage. But for odds, we only use this ratio format. Like the odds of winning are 4 to 1 or something like this. Okay, so that's where we're at right there. Eleanor rolls a numbered cube with the numbers 1 to 6 on it. What is the probability that the number she rolls will be a prime number? Well, prime numbers, 1, 2, 3, 4, 5, 6. 1, 2, 3 are your primes. 5. Okay. These are good little questions here. I didn't post the answers. I will though, but try these out. Okay, I'll post the answers there later today, and this is what we're looking at here. These questions, they're the questions I've given you there for the from the back of the book. They're the odd numbered questions. They're okay, but the real questions I really want you guys to focus on is the questions in the PowerPoint. Okay, there's probably 20 or 30 questions there that I'm not going to go through each one by one, but try these out. And I'll post the answers there later today, because this is everything we do there today is going to carry on through to next week when we do the normal distribution, because the normal distribution is exactly all about probability, right? Because you guys there in the quiz and the test there last week, what's the probability of choosing someone there within the first deviation? Well, you got 34%, 34%, so it's 68%, right? What are the odds of choosing somebody within the second deviation? 95%. What are the odds of choosing somebody there within all three deviations? 99.7. That's where we're going to go there. So try these out. I'll post them there later today. What is the probability of selecting a card with a heart? Well, you've got 13 hearts divided by 52. What are the odds of selecting a card with a red jack? Convert 12% into a decimal and lowest term fraction. I like that one. Percentage just means 100. So 12 divided by 100. Okay, you reduce that to lowest terms. That should be familiar. So 12 divided by 100, you reduce it down to 3 divided by 25. And then you could calculate all this. There's your fraction and all that kind of stuff. Okay. Now, see, we're already halfway through, and basically all we've done is probability, the opposite probability, and odds. Okay. Find the probability of selecting a card with a heart or a spade, or find the probability of selecting a card with a 9 or a heart. So here now you're not just looking at one parameter. Now you're using two. So find the probability of selecting a card with a heart or a spade. Well, and the key word here is or. This is called the addition rule. And whenever you see or, ding, 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 addition rule. This is one you use. And you see what we've got here now is you're looking for the probability of two, what we call mutually exclusive. They're completely unrelated to each other. What's the probability of choosing a heart or the probability of choosing a spade? Completely different bananas. But here we're going to put them together. And this is called the addition rule. Why? Because we're going to add. Okay? The trick with this one, though, is that there may be overlap. There may not be, but if there is overlap, you may have to subtract it. See? The probability of event A or B happening is equal to the probability of A. Easy peasy, we can do that. Number of outcomes divided by total number, plus the probability of B, the total number desired outcomes divided by total number. You add them together, and then there might be overlap. And I'll show you this there. Not too bad, not too bad. Let's have a look. So what is the probability of selecting a card with a heart or a spade? Okay, so the probability of choosing a heart, 13 divided by 52. Easy peasy. The probability of choosing a spade, well, there's 13 again, 13 in the space, so it's 13 divided by 52. And so therefore the probability of choosing a heart or a spade is 13 over 52 plus 13 over 52. And you remember your fractions? We'll have to add fractions here. So you got 26 divided by 52, which happens to be 1/2, which gives me a decimal of 0.5, which gives me the percentage of 50%. Okay? And you see here that the hearts are completely distinct from spades. So there's no overlap. So I don't have to subtract anything. But have a look at this one. What is the probability of selecting a card with a 9 or a heart? So let's break this down here. The probability of choosing a 9, well, there's 4 9s in a deck, right? So it's 4 divided by 52. Good. The probability of choosing a heart. Well, there's 13 hearts in the deck, so 13 divided by 52. All right. But wait a second. There is 1 9 that falls into both categories. You've got a 9 of hearts, and there's also a 9 of hearts here. Okay? So, you have to subtract 1. It could be from here, or it could be from here. But that's what's going on here, is that's this overlap, where the 9 is falling into both categories. You can't have that. All right? So you got to subtract 1 of those away. And what we do is, probability of a heart there, we just took this one. You could do it to this one. We just go 13 minus 1. We get that 1 9 out of there because it's already been included in the other group, right? 4 9s are here, okay? You can't have that 9 in here as well, okay? So 13 minus 1 is 52, so you have 12 divided by 52. So therefore, the probability of choosing a 9 or a heart is 4 divided by 52. There's your 9s. 12 divided by 52, right? Because we just did that there. We removed that 9. You add them up. 16 divided by 52 is 4 divided by 13, which then you can find the decimal, and then there you can find the percentage, if need be. Okay? So that's what's going on there. If you see the word or, it's addition rule, this is what you're using. Because I'm in a couple slides there, you're going to see the word and it is not this formula, okay? So or means addition rule. So we got that one there. Let's have a look here. And just an example of no group overlap. So here I got vegetarians, meat lovers, I got diabetic, and high blood pressure. All right, I didn't include the totals in here, but you can. So what is the probability of selecting a vegetarian with diabetes or a vegetarian with high blood pressure? Well, here we go. Vegetarian with diabetes is 16. And the vegetarian there with high blood pressure is 25. But before we do any of that, I usually don't give it to you. I'll give you a space in the table. Like I'll give you this information that you see right there, but I won't give you the totals. You just got to take calculator and add them up, but I'll give you a space there. And you see you need to add up the totals, right? What is a total number of people? Well, you add them all up. You got 16, 25, 32, 20. Why is that? Why can't I see that? What's going on here? 22 and 27. And you just add them all up. So there's 90 people total. So what is the probability of selecting a vegetarian with diabetes and high blood pressure? Well, break them up. This is how I do it. The probability of vegetarian with diabetes is 16 divided by 90. Probability of vegetarian with high BP, 25 divided by 90. They are completely different. There's no overlap. So you just add them up. Away you go. Okay? Let's have a look at one there that has overlap. What is the probability of selecting a meat lover or person with high blood pressure? They're still 90. Okay, it's exactly the same there. So break it all up. What is the probability of selecting a meat lover? Well, the probability, and this is how I do it, probability of ML, meat lover. That's it. So your meat lovers, what do we got here? Well, these guys here are all meat lovers, right? So I got 22 plus 27. 22 plus 27 divided by, and there you go, 49 divided by 90. Okay, that's the probability of choosing a meat lover. Well, probability of a person there with high blood pressure. Well, high blood pressure. I got 25 and 27. 25 and 27, so there's my probability of just choosing somebody with high blood pressure. But you see the issue here? There's my meat lovers. There's my high blood pressure. Is there overlap? Okay, and I'm not going to tell you on a test or a quiz if there's overlap or not. You've got to use deductive reasoning. Okay, and that's this course here. Will you be using statistics greatly where you go, where your guys are going? You guys go on and get. I encourage you go on and get a bachelor and a master's. Go on, don't lifelong learning. That's what it's all about. But what we're talking about here, deductive reasoning, you've got to be able to figure this out. Okay, and when you're dealing with addition, I'm going to get you on this one. Okay, so where is the overlap? Here's my meat lovers. Here's my high blood pressure. You'll see there that 27 has been included in both. Okay, you can't have them in both. So what you got to do is subtract 27 from one of them. Doesn't matter. So you add them both up. There's your 49 over 90. There's your 52 over 90 minus one of those 27s. Okay, and that gives you 74 over 90, which then you could reduce it and then find your decimal and find your percentage. Okay, so that's what we're looking for there. That's a great example of this, the idea there of overlap, that you have to take that one out. Okay, what do we got going on here? Okay, here we go. Find the probability. Now, the wording is a little different here. Find the probability of selecting a king and then a queen. So, you have your deck of cards and you're going to choose one card and then you're going to choose another card. Okay? And you see here, when you replace the first deck or the first card back into the deck. So you take your king or you take your card, put it back into the deck, shuffle it again, and then choose another card. So this is called with replacement. With replacement. Okay? Or we could find the probability of selecting a king and then a queen without replacement. Without replacement. Good. So you see the difference here. I'm choosing two cards in a row in succession. All right? Take the first card, look at it. I could either put it back into the deck, which now there's 52 cards again. I take the first card, there was 52. I could put the card back, choose again. There's another 52 cards to choose from. Without replacement, though, the second example here, I choose the one card, and there's 52 cards in the deck. So I take one of them. So that probability is out of 52. And now I'm going to choose another card from that same deck, but it's -1. So now my total number is 51. It's okay, I got lots of examples here. This is called the multiplication rule. And the key word here is and. All right? With the addition rule, it was what's the probability of choosing a heart or a spade? For multiplication rule, what are the odds of choosing a heart and then a spade? Different. The key word here is and. And you'll see here the probability of choosing A and then B is equal to the probability of A times the probability of B. And just to let you know, the addition there, you do get some pretty decent percentages when you're using the addition rule. Choosing a heart or a spade, okay, it's 50% or all these kinds of things. But for the multiplication rule, the percentages get very small. Like, what are the odds of, or what are the, I keep saying that now. What is the probability of choosing a king and then a queen? It's not very likely, okay? So, count with or without replacement. The calculation using the multiplication rule depends on how events are counted. You can count with replacement, no change in probability, or you can do it without replacement. You're changing the total number. Again, if you do not replace that back into the deck or the bag of marbles or whatever, now you have changed the probability from out of 52 to now out of 51. And it works the same there. If I have a bag of 30 marbles, okay, and what are the odds of choosing this marble and then that marble? Well, close my eyes, I take one marble, you could put it back in the bag, that would, and then choose another marble that would maintain your same probability out of whatever total marbles. But if you take that one marble and don't put it back and then choose another marble, you've now altered the total number of outcomes. So just be careful. So with replacement, subject returns to group. You put the card back in the deck, or you put the marble back in the bag. Total possible outcomes does not change, meaning the probability doesn't change. Without replacement, the subject does not return back to the group. The card is not put back in the deck. The marble is not put back in the bag. And you choose again. You have now changed the total number of outcomes. You've changed the sample space. And the probability has changed. Show you some examples here. It's not too bad. Here we've got smokers, non-smokers. We got right ventricle hypertrophy and left ventricle hypertrophy. Okay, interesting. A little bit of empirical data here. Somebody did a study. What is the probability of selecting a non-smoker with left ventricle hypertrophy and then a smoker with right ventricle hypertrophy? Count with replacement. It will have that. I have to tell you this. Okay? So look at keywords, because on a quiz, on a test, on the assignment there this afternoon, it's going to be mashed potatoes, right? I'm going to have an addition rule and then a multiplication. You're not even going to know what order it's in. So every question is going to be kind of, brand new, right? So you don't know what the next question is. So you're analyzing this question. What is the probability, okay, of selecting a non-smoker with left ventricle hypertrophy? And then that's your key. That tells you that it's multiplication. Okay? What if I said, what is the probability of selecting a non-smoker with left hypertrophy or a smoker with, that would be the addition rule. Okay? So, and at the end, once you've realized there that this is multiplication rule, because of the and then, I have to give you this. Count with replacement. So you're going to choose one person. Look at the person like they're a card, right? That doesn't even make it. You're going to choose one person, and then before you choose your second person, that first person is going to go back into the mix. So theoretically, you could choose the same person twice. All right? But that's what that means. Count with replacement. So you find your totals. Okay, total number of people. Okay, there's 89 people in here in this study. So find the probability, okay, of a non-smoker left ventricle hypertrophy. Okay, so non-smoker left ventricle hypertrophy is 9 divided by 89. That's your probability, right? Goes right back to slide 1. All right, and you count with replacement. So this number, the denominator, the bottom number, will not change because you're putting that person back in to maintain the probability. So you count with replacement there for the probability of a smoker with right ventricle hypertrophy. So this one here, smoker for right ventricle is 25 right here, divided by 89. And you'll see here, count with replacement, the 89, the denominators will be the same. Okay? And you'll see there what's the probability. Use the multiplication rule. Use a calculator. Okay? Let the calculator be the donkey. You know, let it carry you. Don't stress about these things here. You got 9 over 89 times 25 over 89. Multiply them. In the multiplication rule, you might get some beast numbers. You're not going to have like millions, but it'll definitely be in the thousands. Because you got 89 times 89 is 7,921. Okay? So the probability of choosing this and then this one is about 2.8%. As I said, multiplication rules tend to be very, very small because the likelihood of choosing this and directly after that is pretty low. Okay? So that's an idea. That's an example there with replacement. Now let's look at one there without replacing. So we have the same thing here. I still think we're out of 89. Okay, so everything's good there. So what is the probability of selecting a non-smoker with left ventricle hypertrophy? Okay, and then a smoker with right ventricle hypertrophy. Same question. Count without replacing that person back. Okay, so exactly the same question, just without replacement. So I'm going to choose one, and then I'm going to put that in my pocket, and then I'm going to choose another one. And you see, we originally had 89 people in the study. I've taken one out. Now, for my second choice, we only have 88. The probability has changed. Okay? So, find the probability. 9 out of 89 is exactly the same as it was there before on the previous slide. Count without replacement. 25. Remember previous slide there we had out of 89? Now it's out of 88. Okay? So, and you do your same multiplication, and you'll see there that in this particular case there, it really hasn't changed much, okay? But you do get different numbers. All right? Good. How are you guys doing? Any questions? You guys okay? I hope you guys are doing all right. And here we're into the summary part. Like that's it. Okay, we've covered probability, complementary probability, the law of large numbers. That's just a definition. We've dealt with the odds. We've dealt with the addition rule and multiplication rule. So that's basically where we're at right here. And if you have a look, compare addition to the multiplication rule. And I've given you 4 examples here. What is the probability of selecting a king or a queen? Well, only selecting one card here, the probability of selecting a king or a queen here, or this is your addition rule. So there are 4 kings divided by 52, there are 4 queens divided by 52, and 8 divided by 52, away you go, 15.4%. Okay? What is the probability of selecting a king and then a queen with replacement? Okay? So you're selecting 2 cards, and then that tells you multiplication. So what is the probability of selecting a king and then a queen with replacing? So the numbers on the bottom should be the same. 4 divided by 52 times 4 divided by 52 is equal to 16 and all this. And you'll see there, look at the difference. The probability of choosing a king or a queen, 15.4%. The probability of choosing a king and then a queen with replacement is not even 1%. What is the probability of selecting a king and then a queen without replacement? And you see here that your probability has actually gone up because your second card, you've reduced your sample space because you've taken that one card out. So now your sample space is not 52, it is 51. Okay? Because I chose the first card, which is 4 to 52, and I keep that card. So now my sample space is only 51, so it'll be 4 divided by 51, multiply them out. And you do get some nutty numbers here. Okay? Please don't round, don't make any alterations. These numbers, and and make sure the calculator spits out the right number, okay? Because these numbers here will get into the thousands, all right? And 4 divided by, and then you reduce it. And if you guys have any trouble with reducing fractions, adding fractions, multiplying fractions, shoot me an email. We'll set up a 10-minute WebEx and we'll get her going, okay? Don't let fractions scare you. They're not bad. What is the probability of selecting a king and then another king without replacement? Aha! So the probability of choosing a king and then another king. So your first king, there's 4 of them, divided by 52. And then you keep that king. You've got it in your pocket. So what's the probability of choosing another king from the deck? Well, there's not 52 cards anymore because I got 1. So there's 51 cards in my sample space. There's 4 kings in a deck. I've got 1, so now there's only 3 left in there. So 4 divided by 52 times 3 divided by 51. Multiply them all out, and there you go. Okay? That's what we're talking about there. I've got some questions here. Try these out. Multiplication rule without replacement. 3 cards are drawn from an ordinary deck and not replaced. Find the probability of these events. So here we're dealing with 3. I'm going to choose the 1 card, another card, and a 3rd card. Okay? But be careful. 3 cards are drawn from an ordinary deck and not replaced. So I take 1 card, put it in my pocket, take another card, put it in my pocket, and I'll choose another card. All right? And you'll see there that it was out of 52, then it'll be out of 51, and then it'll be out of 50. All right? Try these out here. I'll post some answers there today, but they shouldn't be that bad. And just to be careful, addition rule, choose 1 card with 2 parameters, but both parameters. The thing about this one there is you got to be careful if there's overlap. Okay? For the addition rule, if there's any overlap, one of those overlaps has to be subtracted. That's the trick for addition rule. Okay? Multiplication rule, you just got to be careful of with replacement or without replacement. Okay? If in the case of choosing 3 successive jacks or clubs, then both the numerator and the denominator will drop by 1. Try this one right here, getting 3 jacks in a row. All right? And without replacing. Try that out. That's a good one. I like that one. Okay? Again, more questions here. I'll post the answers there later today, or but try these out. Here we're talking about an urn contains 3 balls, 3 red balls, 2 blue balls, and 5 white balls. I got 3 red, 2 blue, 5 white. So what's my total sample space? I got 10, right? I got 10 total. A ball is selected and its color noted. Then it is replaced. It's put back in. And a second ball is selected and its color noted. Find the probability of each of these. Selecting 2 blue, selecting 1 blue and 1 white. Try these out. I'll post answers there today. It's good. And then this only deals with section there, 5.1 and 5.2. So that's what you're looking for there. The review questions there, you can try them out. If you only do the odd ones, the answers are in the back. But where I want you guys to focus there is try some of these, but try these ones. These are the ones I want you to do because these are the style you're going to see on your assignment there later this afternoon, your quiz and your test. Okay? All these different questions here. That's a good one right there. You can practice these ones out. You've got the answers, and I'll post all these, okay? On the assignment, on the quiz, you'll see I love these little charts. You know what I mean? You've got a total coming down here, total there, total there, total there. So I think that is, we are on the nitty gritty. And that's it. You guys have any questions? Talk to me. What do we got? If you guys got nothing, I got nothing. but your assignment there will be posted there this afternoon. I'm trying to work on it. It's done. It's been done for a couple days, but I'm trying to get it into multiple choice form because it's easier for you guys, so you guys don't have to be, and I really appreciate this. You guys, the extra effort of taking pictures and these kinds of things. I know it's been a bit of a pain in the butt, but you guys are just doing great. And test 2 marks should be posted there by tonight or tomorrow morning. And again, if you see a 0, if you see something funny with your mark, just shoot me an email. And because remember, a 0 doesn't mean I'm being evil. Excellent, you got it. No, it just means I can't find it. And I put a 0 in there because I know you guys, I think you guys get an email or a notification that a mark has been updated. And if you guys see a goose egg there, you guys are going to email me, which is the whole point. I don't want any 0s. I want 90s. I do. And you guys are getting them. You got class average is pretty good. Keep going. The quiz, the marks were a little lower. They were down probably about 10%, which is still great. It's kind of normal, all right. But the next 3 weeks of the stats course, it's going to get a little heavy. Okay, so do not slack off, and I apologize there that the heaviness is kind of happening when everything else is getting heavy, but don't let this stuff slide, okay, because as best as I can see it, test 2 you just did, you have the assignment that's going to go out there this aft, you have quiz 2, and you have, quiz 3 and test 3. So 20% for test 3, 5% for the quiz, and I think the assignment is 8%. Okay, so what are we looking at? There's still 33% of the course to go. That's enormous amount of meat on the bone. If you're not happy with your mark, there is still so many marks to go that you can pull off an A. If you've got an A and you just slack off, you know what I mean? There's still room to fail this. So please don't let this go. Don't take your foot off the gas. Practice the questions here. If you're having any issues, let me know. But I think you guys are doing great. Get at it. Keep on it. I'll send an announcement out there this afternoon there for when the assignment's posted, and also within the same announcement, I'll tell you there that the answers have been posted there for the PowerPoint here. But hopefully you guys are doing all right. If you have any questions, let me know. Other than that, get out of here and enjoy your day. Thanks, guys. Thank you, Jade. Thank you. Thank you, Elena. I hope you're doing good there, Jesse and Megan. Keep at it. Let me know if you guys have any questions. Thanks, guys.